So I think it's already time to start. So this is Ipsecme working group meeting. I'm the host, Tero Kivinen. David is not here this week. And I don't see him remotely attending, so, but anyway. So just a notepad, you've probably seen it already before. If not, just read it very quickly because I'm going forward now. And so the first things, we need some note takers. Any volunteers, or should I assign some people? I was thinking about using a Etherpad for that, so it actually have good thing to have multiple people who can actually write in their Harkins. Would you be willing to do some note taking?
Yeah.
Okay. I would like to have a second one also. Okay, yeah, good. Just use the Etherpad. The link is there. Or you can go to the, if you go to the data tracker agenda, there's a link to the Etherpad. Yeah. All right, then chapter scribe. Most likely just, typing in if there's a question. Okay, so you can follow. I have it also here in that screen, but I mean, I might not be noticing. Good. All right. So blue sheets are already going around. And then we have the first things is the agenda. Do we have any modifications on or things that people would add to agenda or remove or change the order? I know that Daniel is going to be in other meeting for first half an hour or 40 minutes or something like so. So we have to take slow if it's early parts. Because otherwise we might run into his presentations while he is not here yet. But anyway, so we have actually very not that much stuff to do here and quite a lot of time, so shouldn't be having any problems with times. So any modifications to agenda or anything like that? If not, I think we go forward then. So we have been lazy, and I mean chairs and also the working group. We haven't been done that much since the last IETF, and I think this is it's actually been bad. So we actually managed to get the EDDS out as an RFC, which is good. We have had some discussion with split DNS, and I think it's going to be going forward now, hopefully. We have done working group last call. Okay, do you have some?
Paul Wouters. So on the split DNS, everything should be okay. It's back at the AD, and I think we're just waiting for an AD to.
Yeah, I think
it's on the
agenda very soon, so it should be out, getting ready to get
split DNS.
All right. And then we have done the working group last call for implicit IV. I did see a couple of reviews, but if there's any people wanting to do more. And do people think that that document is actually ready for going out? I see some people nodding, saying that it probably should be. So I will start getting this write-up done and so on and putting it out. Then we have the QRI version 2, which is has been in this kind of stopped state for some time. There have been people commenting on it, but there hasn't been, any. Well, I think we started a working group last call in May, and we never stopped it. But if you have any comment on,
Valery Smyslov just want to correct. It is not ready for guilds. It is in VGNC since August.
Yeah,
it's 3 months.
Yeah, that's actually. But I haven't actually seen that many comments on it.
So, Paul Wouters, there's actually been a lot of interop happening. We've done interop tests about this, so this is more than ready to move on.
All right, so you think that it should be ready, and we should put that one out or so? So I should probably start a write-up work on that also. All right, so then we have the IPv6, IPv4 codes that was accepted as a working group document a few weeks ago. And the reason for it was accepted because the authors actually contacted me and say, okay, I would like to get this one done. So if other people have documents that they want to get, worked on, they should start working on them and contact the chairs and ask, okay, should we start, is your document ready for adoption call or should we do something? I mean, I'm not going to be going on hunting people and say, okay, is your draft now, is your individual draft now ready? Should we take it as a working group draft? If you think it is ready, come to us and say that, okay, this is ready, should we start? And then I will check it out and, then we make an adoption call or so on. So if you have other documents that we want to put forward, please do that. I think for example, the auxiliary stuff might be soon ready or something like that.
Yeah, Paul Wouters. Yeah, there's also the labeled IPsec one that I need to push back to the working group. So it's my fault that I'm behind on that.
That's why I was not saying it's only the chairs. All right, so that's the working group status for the drafts that we have as a working group drafts now. Okay, then we have a couple of work items, and we have completely new stuff that is not really something that we don't have that in our charter. It's more or less clarification stuff, such as the PS key authentication by both voters. Then we have some implementation issues coming from Gallery. I think that was actually very good to have some implementation outs and noticing what's problematic with the current specification, and perhaps we need to start working on this document on that or do something else. And then we have a couple of documents about one document about the compression mode for ESP, and then the IQ 2 notifications for IPv6 and IPv4. Those last two ones, I think, is still in more like there's some discussion about how to do it. The first two one are more like this kind of should be just more like for information and think about what to do next. All right, so the next is Paul. The red one.
I see we no longer have pink boxes, but pink crosses. Yes, the targeting was easier.
So that actually goes by. Okay, now. Here.
Okay. So we saw another CVE this year about weak pre-shared keys. So another attack, they optimized it slightly, and we thought that with only IQ1 aggressive mode, they could attack this offline, but now they came up with some new technology, so now they can do other modes of attacking pre-shared keys offline as well. They just have to gather a little bit more data, and then they can do another dictionary attack against IQ1. And this has happened a lot of times, but it keeps coming back to us. So we're trying to tell people to use strong pre-shared keys, but they don't. We tell it here in RFC 7296. We can say it is common but insecure practice, but we then tell them how to configure it anyway. We say it another time in the same RFC. Deriving a shared secret from a password, name, or other low entropy source is not secure. Please don't do this. Well, people do it anyway. And then in the new PPK draft, we of course also say, well, these PPKs should also be really secure. They should be at least 256 bits of entropy. And we know from experience, from like, I guess, 15, 20 years of experience, that people just don't do this. We have FIPS 198 section 3 tells us some minimum pre-shared key strength that we need to use. So this one's actually, for instance, implemented by LibreSwan only if you run in FIPS mode. Ironically, because the library crashed when this happened, because the underlying crypto library actually properly implemented this and not LibreSwan itself. But we fixed that. And then there's another FIPS publication I quoted in here because after reading this, I actually didn't really fully understand what we should do here. So it's a little, but again, it's guidance to people on how to use strong pre-shared keys. But users are not implementers, so it's nice that implementers read RFCs and the implementers, but they don't force users to have strong pre-shared keys. So why do people still use pre-shared keys? The biggest reason, I think, is that when you have a site-to-site VPN, there's two organizations involved and you do not have a shared trust. So you cannot use certificates because who will be the root CA that has the ultimate key? So people fall back to using pre-shared keys. And the same for instance, on certain operating systems, you cannot just install a certificate because traditionally certificates go into the system store, not the user store, and then you cannot install a certificate without administrative privileges. So people use pre-shared keys because they don't require that level of access on the machine. And so I think this is like over the last 15 years, if I look at how has IPsec been attacked, we've actually more or less the protocol has withstood any attacks except the weak pre-shared keys. The sloth attack came close, but we had some randomness in the SPI that prevented that attack. But this is basically our biggest problem for the last 15 years, and I don't see it improving. So my question is, should we do something? And this sort of originated about, I think, 2 years ago. I did something in our implementation, LibreSwan. I put some checks in on minimum length and minimum strength of the entropy. And I immediately had 3 other developers tell me to pull it out because I shouldn't be making these judgment calls, and it's up to the users if they want to use weak pre-shared keys. I couldn't even determine it properly, like, you know, my sort of really simplistic way of judging entropy didn't work if the user would use 1, 2, 3, 4, 5, 6, 7, 8, 9, because those are all different characters, so really strong entropy. And so what should we do? So I would like to write in a document with the working group that sort of gives more guidance that maybe could be implemented by implementation, so that the implementations start enforcing a minimum strength on pre-shared keys. If you think this is a bad idea, then I would be interested in how otherwise we can reduce the use of weak pre-shared keys. And if you want to be bold, I would also be interested to hear who wants to abolish the pre-shared key method completely, because we have other alternatives that are workable, and in theory, we don't actually have to ever use this. So, comments, feedback?
Dan Harkins. I like the title of this, you know, PSKs will always be weak. Yes, they will, because human beings are using them and we don't handle large, complex things like that very well. I'm not sure about an RC to tell people how strong a PSK should be if nobody's been paying attention to our current recommendations. But what I think we should do is...
So the current recommendations are for the user, and the user doesn't read RFCs.
Okay, that's a good point. I think the problem is that the protocol is weak, and we're demanding that the users use a strong PSK to address the fact that our protocol is weak. So what we should do is make the protocol strong, and then we don't have to worry about whether the users use weak PSKs or not.
So that's bullet number 3 then.
The answer to that is use a PAIC. Now, of course, we went through this a long time ago, and unfortunately the previous chairs of this group completely mishandled the whole thing. It turned into a fiasco, and instead of having a single standards track authentication mode for IKE v2, we have 3 informational ones and some stupid guideline framework thing that nobody implemented any of that stuff.
Right.
So what we should do is, if you want to write another RFC, we should write an RFC that does a PAIC, and we can deprecate all of the other 3 PAIC things in the guide and the framework guideline thing, and just have a secure way of using PSKs. Then we don't have to worry. We take the human element out of that.
Right.
Hi, Joavnir. So you say we should obsolete the PSK method because we have something better, and what is that? I mean, we don't have the PAIC yet. Or
Well, we do
Well,
have a few other
We
ones,
have a
right?
few informational PEGs.
Right.
If we want to do something, I mean, it's very easy in practice to generate a secure PSK. Just take 16 bytes off of dev random and then convert them to hex so it's typable. And people don't want to do that because it's inconvenient, and they don't see how we can never get past that.
They're giving us individual data share. So I think actually the PSKs are never ever meant to be for human readable or writable. They are meant for the machine-to-machine authentication, which means that they should be always, 32 characters long or something like that, very long. And I think you should put into the implementation to say, okay, if you don't have to count the entropy, you just have to put the minimum length on that. And that will actually give you enough hint for people. If you require 32 characters of hex string,
Test.
that's not a hex.
That will be the pre-shared
That
key.
is in the hex string. so when people notice that, okay, what is test in hex, they notice it's easier to just take a proper random number and convert it to the hex.
05, 06.
Yeah, okay, but that's still it's still if people are writing that down, we can't do that. If they are using zero length passwords in their fake, that's still going to be weak.
So that's my serious question.
But
we've
the question-
been punting this to the user all this time and say you should not do stupid things. But
Yep.
should we, as a protocol, take on a little bit more responsibility and say, okay, now we don't let you do stupid things anymore?
But go back to that. So if it's a password, meaning human readable, human rememberable stuff, then we should be using the secret password methods, and we have already those. So you should just perhaps you should implement those. And then you can, say that if anybody wants to use PSK, it must be this long and it must be having this kind of, randomness in it. And if you try something else, it says, oh, sorry, this looks like a password. Go and use this method. And by the way, we also have an EAP, which allows you to do, all kind of weird things.
So we do have AEP, but the problem with AEP is that you also need an authentication provider, and there's a whole bunch of setups. So if you have two organizations that want to do a site-to-site VPN, you don't have a shared AEP infrastructure to do that.
Stanislav Mishlev, Krita Pro. Dan Hawkins was faster than me, and I just wanted to support his position that, in fact, if we allow users to use any keys that are chosen by them, and we always have the problem of selecting human readable something, then yes, we have only one type of mechanism for this, is PEGs. And if someone in this room is not aware of, in CFRG, just 2 days ago, there was a startup process of selecting 1 or 0 or maybe 1+ PEGs that will be recommended. And I believe that the only way to deal with this problem, if we don't want to force users not to use any selected PSKs, then the only way is to use PEG there. So
just to correct, so you're saying the existing PEG RFCs that we have that aren't really well implemented, we should forget about those and wait for CFRG to decide on a PEG and then implement that?
no, I'm not saying that. I'm saying that if now we have some problems of too many PEGs that can be used with IKE now or later, then maybe the way is to wait for CFRG to choose one, or use any PEGs that we have. But my opinion, yes, is that for the third question, is that if we don't restrict users not to use user-selected PSKs, then we only must use PEGs of any secure PEGs as we have.
Just want to echo what the previous said, Hujin from Nokia. I think we should not obsolete the PSK. I mean, it's there. It's easy to understand. Everybody.
So can you speak a little bit closer into the mic?
Oh, sorry. So I think the first comment I have is that we should not obsolete the PSK method. It's used everywhere. Everybody knows how to use it. So it's not going away. We cannot just remove it from the protocol. And if with that, and so that we have to make the protocol stronger, then the only obvious option is PEG.
Valery Smyslov, Plus. So first, I think that third option is not an option because actually the PSK method is quite secure. It's if you use a proper PSK. So from cryptographic point of view, it's absolutely sound. So there's no reason to drop it from IQ2, and you can't make users doing stupid things, even if your implementation will require some, I don't know, checks of PSK. The poor user just will write it down, put this paper in the pocket because it can't remember it. It's difficult to manage such long key. So from protocol point of view, it's very difficult to make users not to do stupid things. It will always happen. And what about, well, and as some previous commenters said, the PAKE is a good option for those people who, for those, if you think that users will still try to use short passwords, short PSKs like passwords, and PAKE is a good option, but unfortunately we don't have a standard way to do it in IQ2 now. We have a framework written, I think, by Tero, and actually I've implemented it once for experimental purposes. Well, not would I say that it's extremely complex, but it adds some complexity to IETF machine, and unfortunately.
Did you find someone to interop with?
No, I've just implemented a framework, not a concrete PAKE method, because there are three information on PAKE methods. I just make a framework to use it with any PAKE, but not real PAKE is implemented. Just to modify state machine, and state machine became more complex than it is now, and it's quite complex even now. So, but probably it's a way to go forward and to try to make it more standard and probably more easy. But please don't drop PSK mode, because I think it's useful and it's cryptographically sound if you use a proper key.
Right. So. But by the way, I don't think writing down the PSKs is so much problematic, because I'm sure all the administrators have that in their email box anyway.
Hi, Sean Turner. Not an implementer, so take this for what it's worth. I agree with Dan. We screwed the PAKE thing up the first time around. I don't know if it's going to get any better if we do it again. I think you're right. Everyone's right. We can't really get rid of PSKs. We have this. Should we write an RC on PSK links and stuff? We have comparable drafts for that, for symmetric keys and how big the keys should be. So it seems like it's plausible that we could actually get away with writing such a draft and coming up with a lightweight algorithm that we could do the strength of entropy, and I'd be willing to help. So. Okay.
Actually, so I want to comment something. There were several people saying that, okay, one of the problems is that the current framework for different secret password authentication methods, none of them were standard, and the reason was that, but we couldn't agree on one. And when we say that, okay, if we pick one, are the other two willing to not to publish them? And they said no, they are going to be coming out as an individual RFCs anyway. So which was would have been ending up in the same kind of situation anyway. The question is now that I think we could of course ask for CFRT, can you pick me one PAKE? And if you can give me as a one PAKE that we can actually use for, they would actually make an internet-wide PAKE, then we can actually secure password out. Then we can actually start move that as a standard, because actually we already have three, and moving one of those as a standard track or full standard or standard would be possible, and that would help the interoperability. But the question is that I don't think we are going to get any results here. Do people think now that we could actually agree on one PAKE? Okay, so people seem to be shaking their heads and saying no. So we could actually ask from the CFRT, but I don't think if CFRT are going to get one. I think their situation is same there. That's my guess. So
Excuse me, Stanislas Mishlev. I am afraid that I think that even if we can choose one peg, then at least there can be selected at most two with really different properties. So, for example, one balanced peg, one augmented peg, so with strict recommendations where to use which. So I believe that clear recommendations can be made and can be used. I believe that FRG will do this.
actually, I think Valerie is in location or in the best position actually to pick one, because if he has an implementation for the for the framework and he implements one and it says that, okay, I have implemented this. If you want to interrupt, try this address with this. Then probably the next one who is implementing it probably going to pick exactly the same. Then we have exactly one. So I hope you implement something and then we can get one secure password method that is going to be used, because not as a standard because it's still informational, but it's going to be the de facto standard because that's everybody implementing.
Yes, so Shleif again. Yes, we had the same discussion on CipherG, and there was a lot of opinions that we should select either 0 or 1. Yes, I think this will be most convenient for everybody. But I'm just saying that at least I'm sure that there will be one clear recommendation for each set of protocols at least.
Dan Harkins again. So getting back to what Stanislav just said, yeah, the CFRG might come out with one balanced, one augmented, but if we were to do a PAKE in for IKV2, I think it should be balanced because either side can be the initiator. If we did an augmented PAKE, we'd basically shoot ourselves in the foot. So the CFRG can standardize an augmented PAKE if they want, but I don't think it should be used here. Now, regarding, could we agree on one PAKE? I don't see why not. If I will volunteer to keep my mouth shut for the entire process if that will help. But I think but I think it could happen. I don't think we should not even attempt it.
All right, so let's take a hum. How many people would actually think that we should try to pick one PAKE? And the other option is that and this is should try doesn't mean that we actually succeed. But I mean, how many people think that we should even try?
Who we?
IPsec, as actually what I see, yes, that's actually a good question
because it is CFRG who will pick.
If you get something from the CFRG, is the CFRG working on this to selecting one? It is. Okay, and do anybody has to know what the time frame is going to be?
Stanislas Mishlev. So there was a discussion in CipherG, and the process just started on Monday. So Alexei Melnikov asked for questions which to ask for each PAK, and then the plan is that Crypto panel will review all existing PAKs to select or to make some recommendations and try to select one. If I am not mistaken, we don't have an exact time frame now, but I hope that the process won't take years. So I believe that we can be more or less quick here. So we had a lot of discussions on PAKs. So I think that all of us understand what is good and what is bad in each PAKs. And also a lot of PAKs in CipherG have a lot things in common. So I believe we can select one.
Right. So if CFRG is going to be picking one anyway, then I think we might be actually coming back to this question, because this is also probably also going to require some kind of chartering change. So it's we can't do it now completely, but I think that's something we probably could come back when they are a little bit further on in the process.
Valery Smyslov, and their opinion is that they would pick 0 or more.
Yeah, if they end up in 0, then we are in the same position we are now.
And even if they pick one, they could pick an augmented one. So if we have a requirement that we would like them to suggest a balanced PAKE for us, then that information should probably be given to CFRG.
But actually, in this is actually coming back to this comment I was giving out earlier. that if you are actually having balanced connections, meaning either one can be initiator, which means that it's going to be this kind of VPN site to site, there is no excuse of not using strong, wrong password key. The cases where we actually use the weak PS keys mostly is where you have somebody typing in the password, or somebody actually has to remember it, or you have, this kind of, one-sided. You have a server and you have a laptops and so on. So yes, it would be better to get the balanced one because then you can use it everywhere. I think we could live with the augmented one if it's a one.
Okay, I will slightly disagree with you on that. I think the only people that really use strong PSKs are the kind of people that drive around in armored cars and have people with guns that deliver CDs to people. That's those are the people that are worried about quantum computers, basically. So everybody else that types this stuff into a router is not doing 256 bits of entropy.
Yeah. This actually also gives a good question. Should we actually in the PPK require more strict, length restrictions? Say that, for example, that it must be always at least this long, and put it in our. We can do that in the PSK very easy because people are using it already. But for PPK with the quantum stuff, because the whole reason there is to be secure against those, so we better have it be long enough that you can actually brute force it.
Here on Chef, so I'd like to plus one then that we need a PAKE, we need a balanced PAKE, even for the people who in theory should have done better and should have been using good PSKs, but they in reality don't. And this is input that we should bring more formally into CFRG.
Hi, channeling Scott Fleur. About balanced PAKEs, we don't actually need it as the PSKs are different in the two directions. Hence, the initiator proves its PSK to the responder, and the responder proves its PSK to the initiator.
Paul Wouters. So Scott is right in theory and according to the protocol, but I have never ever in my life experienced people that have PSKs that are different in both directions.
I got to agree on that. I think our test system did allow that. All right, so no more comments on this. So I think we should have put down in the, for the chairs to I think my take on this was that we should ask for CFRG to have, to pick preferred balanced PAKE so we can actually use it here. And we can probably make some kind of, request to them from the chairs about that. So if you can put that down in the minutes as an action point for chairs, so we try to make some kind of email that will first send to the list and then ask if this is okay, and then you can bash it and then we can fix it and do it, loop it around a couple of times before we can send it out. All right, so I think that's all for that. Let's move to the next one then.
Hello, once more, Valery Smyslov. So I will talk to you about some experience of implementing IETF over TCP. So TCP encapsulation was defined in RFC 8229. It was more than a year ago. That was published, and the idea is quite simple. Just use another transport, and so it modifies IKE behavior in some ways. For example, original initiator is responsible for restoring TCP connection if it is broken, and there are some special behavior with Mobike, with net keep alive, with IKE fragmentation. So anyway, the RFC is not long and seem to be quite simple, but as usual, devil is in details. So having implemented it, we got some experience, and we think that some things are either omitted from RFC or not clarified quite well, and some of them are just for optimization and probably some optimal behavior of the protocol, and a few things are really important for reliability or interoperability. So, well, I will mark those which are less important and just for only for optimization in blue, and the real important things in red. So first, retransmissions. So IQ2 defines a retransmission policy that exchange initiator is always responsible for retransmitting packets in case it didn't get response in time. So TCP is a reliable protocol, so you don't need to retransmit actually, because TCP takes care of it. And if you retransmit, it in some rare situation, it can even get worse for some congested networks. TCP will try to send all the transmitted messages that is not needed, so it will make congestion even worse. While it's probably extreme for taking into account the type messages are quite small, but still. So there are some situations when you need to retransmit. In case, for example, when TCP is broken and then restored, each party must transmit all outstanding requests, because there's no guarantee that previous request reached the other party before the TCP connection is broken. So there are some changes. Well, using cookie and puzzles. Cookie allows responder to verify initiator's IP address without creating any state. It is defined in IQ2 Core IFC, IQ2 RFC. And with TCP, cookie is less useful because TCP handshake already verifies that initiator IP address is real. Well, there are some attacks on sequence number. Won't talk about it. I'm talking in general. In general, TCP verifies that you are talking with a real IP. Well, there are some TCP extensions that also allows to TCP responded to become stateless TCP cookies, I mean. But anyway, for IKE, a cookie is not really useful with TCP. And moreover, TCP creates a state before the SYN-ACK handshake is TCP responder creates state before SYN-ACK handshake is finished. So cookie is meaningless at this time because it is intended for IKE responder to be stateless, and it is stateful on TCP stack. And still, using puzzles still makes sense because it allows responder to offload some to make initiator do some work to prove that it is really want to connect. Well, and there is some corrections. There must be some correction generating, not correction, but some clarification generated cookie. It is still a local matter, but with TCP, responder must not include port number, initiator port number in the cookie, because it will be different with every TCP connection. So, well then, error handling is AKC init. Again, AQ2 core draft says that AKC init, all responses are not authenticated, are not yet. So initiator need to wait some time, even if it receives error notification, for example, no proposal chosen, it will need to wait some time before some more packets arrive, because this notification can be fought probably. With UDP, it's all true, with TCP not. Well, if you receive error notification with TCP, it means that either it is a response from a real responder, or the TCP connection is hijacked. If it is hijacked, you will never receive a response from genuine responder. So there is no way, there's no need to wait. You can just immediately act on the error notification. So it's just an optimization. Of course, you can wait if you want, just to boost the user. Well, interaction with mobile. Again, RFC 8229 have sections that describe how mobile should handle with TCP connection, and it says that first you must try, if IP address is changed, you first must try UDP transport and then switch back to TCP if no response is received. But a few clarifications should be added. First, clarification, you must recalculate net detection, source IP, net detection, destination identification, because ports will be different in any case with UDP and TCP. And the message ID of TCP-based exchange must remain the same. So it's important for interoperability. So, and probably one of the most difficult problems with TCP-based IQ2 is interaction with HA clusters. So there is an RFC 6311, sorry, that defines a way how cluster and client need to communicate in case in cluster failover. So if failover takes place, the new active node immediately sends an informational exchange which contains a new message ID and optional new sequence number, ESP sequence number, so that in case any messages are lost during failover, the SA can be used after failover. So the problem is that in TCP, after failover, you will probably not have a TCP connection. It is broken because, well, it is possible it is up that then you need to synchronize TCP state, constantly synchronize TCP state between backup node and active node. It is not always practical. So if you synchronize only IX state, TCP connection will be broken after failover. And at this case, in this situation, the new active node cannot send anything because it is not an original initiator. It needs to wait until TCP connection is restored. But the client is not aware the connection is broken. So if there is nothing to send, it's just waits and sits and backs. So we have some kind of clutch, deadlock. So I don't know what to advise in this situation. Probably a client need to periodically send KPIs package just in case every, I don't know, 5 seconds or 10 seconds. So that if there's no traffic, of course, if there's no traffic from client to server, so the connection is restored. So that it gets known that connection is broken and this connection is restored at failover. Or the other option is to make cluster wait, don't immediately send, don't immediately initiate information exchange and wait for, I don't know, unpredictable amount of time before client wakes up and restores the connection. So I don't have immediate opinion what to do. Well, and a few words about TCP proxies. So I've got some response on my list that some people initially implemented TCP encapsulation using proxies that and unmodified IKE implementations. So I think that having thought about it, I think that it is generally possible, but there are a few things that I don't know how to implement with proxy, and things that in general, not in general, but in these cases, proxy won't work. So it can be just for playgrounds and not for implementation that you want to ship. So, for example, if connection is broken, TCP, and if originally initiated is a modified IKE behind TCP proxy, and TCP connection is broken, this initiator is not known about it, so it won't restore it in timely fashion. It will restore it only if it sends some, it has some new data to send. And so if original responder is a modified IKE behind TCP proxy, so responder will try to send packet if there is no connection, TCP connection, if connection is broken. Of course, all the situation happen if connection is broken. So everything, if everything is up, everything will work. So, but sometimes it happens. So question, comment. Some probably there are some more issues with TCP installations that I didn't yet come across. Probably somebody else come across. And my main question, isn't it time for 8229 bis or not yet? Or is it ever needed?
Tommy Polly, Apple. Thank you for going over the analysis of this and doing the testing on it. Just for also everyone in the working group, we've started doing some interop on this to do the testing between our deployments, so that's good. Just regarding the last question, I agree that there are things to improve upon. I would probably prefer to wait a little bit, maybe for more of like these, if we have other issues or we want more deployment experience to put in there. I think none of these, I believe, are like critical enough to require something show-stopping on it. But that's just my opinion. Could we jump back some slides, just kind of go give individual responses to some of the issues? Maybe just start at the beginning. Yeah. So I'm not sure exactly why you mark this one as red here. So
It's
one is
orange.
okay,
Yellow.
right, or even as a kind of like a high-level issue. So
Okay.
part of the reason why our implementations do retransmit is there may be this proxy scenario. There may be an endpoint that's not directly attached to the TCP connection. And I think in the case of retransmits, the fact that we are often tunneling TCP connections in ESP over this is far more of a concern than the IKE retransmissions, because the IKE packets themselves are not going to be really contributing all that much to the congestion, which is why the document has a whole bunch of considerations for why congestion inside congestion is potentially problematic. It's certainly at high reordering or high loss rates. That's why this is a fallback. So I see this one as a thing to mention, but I think I disagree with the assumption there. Next one.
Actually, want to go. Paul, do you have also questions, comments for most of those? Okay, so. All right, so because I was thinking about if other people have other comments on the same slide, it would be actually better to take them at the same time. So, but if he doesn't, then go for
Okay. So on this next one, I think that's good to bring up. I don't think we really considered cookie and puzzle totally. With the cookie calculation, including the port number, because it's often going to be different, isn't that also the case for UDP behind NATs? I mean, the reason that we switch over to 40500 is that we can be behind a NAT, and your port number is going to look different.
It's probably, but still it can be the same with TCP. It will always be different.
But I guess shouldn't the cookie calculation always not include the initial
Okay.
port number? It's not unique.
Actually, it's a local matter, so it's probably I will probably mistaken painted it in red because cookie calculation is a local matter, and an example given an RFC doesn't include port, but some implementation may include it because it's a local matter. So we should just make an advice that port must not be included.
Actually, for NATs, it's usually not a problem because I mean the NATs map the port number always to the same. So from the responders to servers point of view, the source port is always going to be this random number. It's not the same that was in the sender's end, but because this cookie is calculated by the server and it verifies that it comes back from the same client, from the same source port. So.
Okay, and so you're assuming essentially that this is quick enough.
Yeah.
Because the cookie challenge happens back to back.
Yeah,
that
it's
not
I mean,
quick.
the NAT is supposed to keep your mappings up for that
Um,
long. For TCP, you're not probably going to get the same port.
Right. Okay. Yoav just pointed out that I think the cookie calculation suggestion in the RFC does not include any ports.
Yes,
But
it's a local matter, so it's just.
I just want to say that we do have experience where there's the NATs actually causing problems by very quickly rerouting the port, and it seems that some telcos in the Middle East sometimes do this on purpose as well. So yeah, this did never ever include the port number.
Okay.
So, next.
So thank you. Next. Yeah, this is just optimization. Yeah, that's fine. So again, here with the interaction with Mobike, I think certainly it was my assumption that you would be recalculating the NAT detection upon doing this. It's kind of like whenever you do a Mobike packet, it should be identical what you do over TCP and UDP. Do you not agree?
I'm not sure because ports were difficult. Anyway, port will be difficult, and NAT detection includes port. So if you send over TCP unmodified packet, then NAT will erroneous be detected, even if it is no NAT. I don't know whether it is good or bad, but well, so that NAT detection to work correct, you must recalculate.
So when we are switching IP addresses in Mobike, you always must send the packet exactly as the same. You never ever can modify it. You can't recalculate the NAT detection IPs because that will break the system. The problem is that you don't know if your original UDP packet ended at the other end. It might have. The response might have get lost. And then if you retransmit it in TCP with a different content, he doesn't know what to do.
Sure.
So that's why you never ever modify it. But on the other hand, Mobike says that if anything goes wrong when you are switching the addresses, if you switch the address, if you are sending for the same thing in a Mobike, if you are doing update address, IP address, if the IP address you are trying to use, you can't use it, you move the next one, you still send the original saying, oh, I'm moving this address, but actually using different address. Then when you finish that, you immediately do new update IP address to the final address. So you first, if you're using your address A first, notice it doesn't work, switch to B, send an update IP address for B. Notice that doesn't work either. You switch to C, still using that I'm claiming to be using B. And when that C works, then you redo the update IP addresses again for C now, and with the unmodified, then you actually do. And you should do the same with the NAT detection IP. So if you notice that, oh, the information I used calculating NAT detection IP changed while I was sending the packet out, I should do, update IP address again to verify that we are in sync in both ends.
Well, you describe a multi-home scenario, and in case your local address is changed, there is only one address that you can send from at any point of time. You can't try different addresses. Your address is changed. You don't have previous one.
David Skenazy, Google. I'm confused. In my understanding, and please do correct me if I'm wrong, the purpose of NAT detection is to know if we're sending over ESP or if we enable UDP encapsulation. If we're encapsulating over TCP, there is no benefit whatsoever in NAT detection. We can just take the results of it and throw them on the floor, right?
So that's true. That's, well, okay, we first try UDP with Mobike, always. So in this case, where NAT detection must be present and currently, well, should be present. Must be present by RFC, by the way. Well, for TCP, of course, we're not more tolerable, so it's not important whether, it's not so important whether you erroneously detect that there is not when there is, yes. But, okay, probably we can mark it in blue.
To simplify this, we could maybe, if and when we change the document, you could say, if you're using TCP encapsulation, you must ignore any NAT detection you receive.
Probably, yes, okay.
All right. What was there one more slide?
Okay.
Or right. Yeah, I think this is a good one to note, and I'm not sure what the cleanest way to handle that is.
Sure.
Yeah. So I think this is one of the areas where I think will be good to have new text. I don't think it's a like a blocker or critical thing, but we should definitely roll it into updates.
Okay.
Yeah. And then proxies. We had mainly been using them on the original responder side, or putting the proxy for the server. As I've described before, I think that's important to have still be possible to work. Okay, that's it.
Paul, so I agree that it's a little too soon yet to do a BIS document. I think these are valuable lessons, and some of them are not fatal yet. And I think we would like to have a little bit more experience, maybe Linux support before we go to a BIS document, because we might actually encounter new problems that we haven't thought about yet.
So, Mark McFadden, I'm also going to do a +1 on it's not ready to do a BIS document. But I actually think the results that you've documented here are really excellent. And listening to the experience that Apple's had, I think is really helpful. And so what I'd suggest, instead of having a BIS, trying to do the BIS work at this point, is to take your document and adopt it as a working group item, and then move it forward as an implementation experience informational track document out of this working group. I think that would be really helpful. And later on, when the working group comes to actually do something about 8229, then use that as a foundation for making the changes.
Okay, question to our chairs.
So Yavnir, well, I also think it's too soon for a BIS document, but rather than write that out as right now as an informational RFC, we could have a working document that lasts for years. I mean, there's no rush to publish it, and eventually it might become 8229 BIS, but it can start with just a documentation of the implementation experience, and then it might mature either way, one way or the other.
That was very close what I was actually going to propose as a chair. I was thinking about we had in IETF 2 we had this clarification document, which was then finally published as an RFC, and then we rolled it into the IETF 2. And but I don't know if it actually was very useful to actually publish it as an this kind of RFC. It could have been also just been out as a informational or just a draft to say, okay, this is a draft where we collect all the problems we have with TCP encapsulation, and when we think we are ready, meaning we are not going to get any more of those, then we would start working on the TCP encapsulation BIS document, and then we would roll all of these information from the draft to this new RFC. And that's of course actually something we don't have a TCP encapsulation BIS in our charter, so that will be requiring chartering change anyway. But that's something that we have time to do, because I mean I understand that this would be at least out for year or something like that. And if we feel that it's actually important to publish this clarification document as an RFC, we can do. But so what's people's opinions on this? Do you think this would be the good option to go forward? So let's make a very basic hum. Who thinks think that we should work on this document even in this working group, even if it's not actually in our current charter? So if you think so, I'm making a hum, and the first question is, do you think we should work on this? Do you think we hum now if you think so? Okay, is there anybody here who want to hum for not to work on here? I'm not hearing any hums on the not working on this. So I think we are going to be working on that. So the question is now, do we actually want to publish this as a document or not, as an RFC? For draft, I think yes. And I have to talk with my ADs anyway if we can actually work on this, even if we are I think we can actually take it as a this kind of item, because it's still a minor clarification that this kind of things that we are supposed to be doing. We are not changing anything or adding new stuff. We are just clarifying the old stuff. So I think but okay. Do you think it actually, okay, let's ask if we, okay, do you think that if we get this clarification document and finished, should it be published as an RFC or not? Or should we just enroll it into the BIS document? So anybody who thinks that we should publish the clarification document, come now. Okay, so you think it's too early to ask them? Okay, that's actually something, yeah, I was actually thinking about asking that first, but all right, so Because people didn't on Tom, I think that's too early.
Pavel, but I think it would be useful to already reformat this document into what would be the BIS document as a skeleton and put all of this already in there and just leave it in a data tracker until we're ready for it.
Actually, I'm not sure about that because I mean, it's sometimes it's actually much more easier for the good thing about the clarification document was that in version 2 was that it was only concentrating on those items that were important for, it was actually, unclear in the previous document. It didn't have 100 pages of, extra stuff that was, would have been hiding the basic, core of the issues. So I think that's, I think that we should start on working on, and it's actually much easier to work on if you can just add an issues there, issue, and not think about what would be actually the, actual solution, how to write the draft, in a way that it actually solves this issue. Because in some cases, we are going to just have an issue and we don't have a solution yet. All right.
Okay, just
so we are going to be working on that. I will talk about our ADs and verify that it's okay and so on. But and I will actually also verify if you can make this a working group document, even if it's not going to be published as an RFC yet, or we don't know if it's going to be published. All right, so
just a moment, a small announcement, displacement information. Despite all this difficulty, we've had a successful interop with Apple, with Tommy, just yesterday. So, just for information.
So I'll clarify. Red Hat is helping the Linux kernel people in adding this. There was about half a year ago an original patch submitted. They thought it was too intrusive into the TCP stack. So that's now being worked on at Red Hat to make it less intrusive. So we do hope to have this in the Linux kernel soon.
all right, I think I saw Daniel come in. The name wasn't enough. All right. And you only have 42 pages of slides.
No, so I'm going to go short for this one. I'm going to compress the presentation. So what we have designed is ESP header compression. And what we actually do is we provide a framework to compress ESP packets. So the motivation is mostly to increase the lifetime of battery-powered device, and while reducing the payload, the size of the payload, we want also to interconnect those devices with the IP world. Most of the compression is taking advantage of the IC agreement, or I mean the establishment and a security association. So we have already agreed on a given number of parameters, and so that's mostly how the compression are based. And we do, we do not change we do not have signaling within the ESP packet, for example. So this is the architecture. So this is the current ESP. So
you are not in the mic if you are talking. And also they can see you.
So why?
Remote people can see you.
So ESP is not so much a spec, but the reason we put different layers is to differentiate the different steps of the process of an ESP packet. So the compressions, if you compress the inner packet, you have to compress it before encrypting it, and most likely before ESP fields are being applied. If you want to compress the ESP fields, it's better to compress those before they have been encrypted. And if you want to compress some of the ESP fields after the encryption, such as the SPI, for example, that's what we call the post-ESP phase. So all the fields are compressed the description of the compressions is provided with what we call rules, EHC rules. And so we defined a number of rules, and then how the compression occurs is a coordination of all these rules. And it's what we call the EHC strategy. So the EHC strategy is mostly saying, well, if we are in this situation, I'm going to compress this field, this field, this field, which means if I am in this situation, I'm going to apply this rule, and this rule. So that is mostly. In some cases, you don't have all the information already in the security association, so you need to provide some extra parameters. And those parameters are provided into what we call the context. So, well, this is mostly what I said. The rules, the context, oh, yeah, the context and the strategy. So this is really how the rules are described, but it's never, well, the rules are mostly here to provide a formal description of the strategy. So they are never agreed. Well, the action of in the previous slide, so the rules, you have a name, you have a field, you may have different fields because you may have one rules that enables the compression of different fields altogether. So you have a field, you have an action associated to the field, and some parameters. So that's basically how we describe the rule. The actions should be, well, you send the value completely, or you just remove that value, or you apply, well, you take this value, for example, you just send the least significant bit of that value, and usually the decompression occurs, you take the value, you derive the complete value from the SA or from, yeah. So checksum, you don't put it. So there are a limited number of actions, and it's pretty obvious. Yeah, so we compress the inner IPv6 header, the ESP fields. There is no one-to-one mapping rules between the rules and the fields. Well, one rule may compress multiple fields. And one field may be compressed differently with different rules. So the context provides all the values, all the information you need. So it might be in some time a value, or sometime in information where you're going to find the value. So the strategy is the coordination of the rules, and so the strategy we define is DIE-TSP. So the purpose of DIE-TSP is to coordinate a set of rules, so selecting and coordinating those rules. How we do that? Well, we have to balance the compression efficiency with the ease to configure it and to apply it to some real use cases. So in some time, for example, we privileged IPv6 over IPv4. So sometimes we had to make some choices, but in most cases, we try to make that compression useful and not to create too much burden. For example, ease of configurations, when we could derive fields of the inner packet from the outer packets, that's the rule we provided. So which means that we avoid to agree on each field of the inner packet. Yeah, most of the elements are provided from the SA. So that's what we apply. So basically, it looks like the strategy is defined, is standardized, needs to be standardized because we only agree on one strategy. And basically it says, if the IP version is 4, then apply this type of rules. If the IP version is 6, apply this set of rules. If it's UDP, apply this set of rules, and so on. So the strategy in itself defines which rules are going to be applied and how it's going to be handled. The number of parameters, because that's what could be scary. How many parameters do we agree to achieve that compression? Well, these are the parameters to achieve any kind of compression, which means that it's 1, 2, 3, 4, 5, 6, 7, 8 different parameters. All of them have default value. So if you don't agree with those, we still perform the compression, and in any type of connection does not need all these parameters to be agreed. So this is the ITSP, I think. Oh yeah, so that's an example. So if you have a single UDP session VPN, so that's mostly a case for IoT, you could so you can compress the sequence number, the SPI, and remove the padding. So you could achieve 61 bytes overhead. And I think it's not even, oh no, I'm not sure I'm including the user implicit IV or not, I'm not sure, but still. If you use that for a traditional VPN, I think it's IPv6 and IPv6, so I don't know how traditional it is, but you still have a 32-bit per packet compression, so still a significant gain. And yeah, so we had an implementation on Kentucky, and we run that over, so I think it's a M3 device. So the funny thing is that, so we had different type of compressions. So we have no compression at all, so it's in red. So we measure the number of bytes you can send, and the corresponding energy. So the reason you have a stair is because usually what matters is the number of radio frame you're sending. And if you're sending a radio frame with 1 byte or a radio frame that is full, I'm not saying the number because I'm going to get it wrong, it's the same cost. So basically, what needs to be optimized is the number of radio frames. So this is why you have some stairs. And the funny thing is that because you can compress the inner packets, it's you can send more data by using a ITSP than not encrypting the data. And actually, with the so the full ITSP is a little bit well, it only applies in very specific cases. But if you have a reasonable compression, the cost is very close to clear text, the cost associated to the clear text. One of the reasons is that the energy consumption is highly related to the number of bytes of frames you're sending rather than the computation. So now how to negotiate all these parameters? So we define an extension, an IV2 extension. And the idea is to, so we use a notify payload. And well, basically the strategy is to say, the initiator says, this is the range of value I'm accepting. The other ones, so accepting, and there are some default values. So unless if you specify nothing, it means you're ready to accept any kind of value, but you can't provide some specific sets of value you're ready to accept on specific fields. The receiver is going to select the value is willing among what you announce being accepting. And if it responded by specifying nothing, it's a default value that is being considered. Well, it looks complex, but it's I think it's pretty obvious. So these are the different values we say. Well, so the reason is that we wanted to optimize the number of bytes for the IoT use case. So in a lot of cases, you will have to specify which are the parameters you would like to choose. So this is the exchange, and well, should work. So we had an implementation on Kentucky. We published those results 1 year ago. There is an ongoing implementation on Riot, and well, we discussed during NetDev during the Montreal meeting, and some of the people were interested when it's going to be a standard to implement it in the Linux kernel. So.
Valery Smyslov, Lewis Plus. So I think that idea to compress to have a header compression is very excited, and well, I like it. But what strikes me is the complexity of the number of parameters and the complexity of negotiation. So for poor user or poor implementer, I think it will be not easy to select all this, to configure all these parameters, so that probably, well, so my question, is it possible to simplify, or probably just not to, I understand, not to take into consideration all possible cases, just to focus on a few most common or most effective cases, and simplify all these number of parameters, because when I look at your RFC, it's I think it's about 50 pages long. No?
Oh,
40.
Maybe you have a lot of examples. I think it's
I don't
20.
know. So it's half of the length of IQ2.
Yeah. So it's true. The thing is that we took a lot of time defining the rules, but it's more. I think the code should be lighter than the descriptions, because the implementation is straightforward, and the rules is just to define formally what we do and to structure the things. But if you have a better way, it's a better. But I don't think it's very much complex, even though it might look at that. And then for the, I understand your comment on simplifying the negotiation.
Yes, it should be my second comment about simplifying the negotiation.
So that's yeah. Anything that's a goal we would like to achieve. I think we were close to achieve that one, because the intent was to say, basically, say what you want, and anything that you don't need is going to take a default value. And the reason for that is that some of the parameters would never matter. So we don't want them. We don't want that the end user configures something that is not going to be useful. So that's one of the reasons. So we just mentioned configure what you need, and the remaining is going to be taking a default value or never going to be used. But yeah, so that's good. You're more focused on the IKV2 extension.
Sure.
Okay. Yeah. We would appreciate feedback.
Paul Wouters. So even though you keep saying that this is really simple and straightforward, I read both the drafts and your presentation, and I listened to it, and I don't understand anything. So I think it's really complicated. Now I'm a little bit biased. I was hoping to kill IPComp, and now you come here with something that is like much more complicated than IPComp was in bells and whistles and features and things. And I'm not sure if it's really justifiable to say, well, there's a few battery-powered devices that could benefit from having a few bytes shaved off here and there. And especially then if you start talking about this has to be simple to configure for the end user. Well, the end user is just going to say, oh, look, I can now, instead of once per 5 minutes, I can now do my temperature measurement once per minute. I can get 5 times more value out of my device. And then we've got all of this complexity, and I don't think that would be really worth it in the end for the protocol. Like, people already say that IPsec and IKE are really complicated, and I think this just adds so much more complication. I would rather have us work on removing IPComp than to add this.
Anyway, we are running out of time. We have one more presentation, so be short.
So how does this compare to RFC 5856, robust header compression for IPsec?
Oh yeah, so yeah, so the thing is, the main difference between ROC and this thing is that you have no inbound signaling. So here we just define rules, which means you don't have the agreement of the rules within the data path. You don't have these learning phases. So because ROC, well, the idea of ROC is basically you have a learning phase. So the first packet is not compressed, and you have all this.
So you're saying this is static and the ROC is more dynamic.
Yeah, exactly. And ROC has never been deployed.
David Skenazy, Google. To answer Paul's points, in terms of the complexity, so yeah, this is a lot simpler than the ROC one, where the goal is, or maybe we need to clarify the draft. Maybe it doesn't look simple, but conceptually, during IQ, you say, hey, we're always going to use this address as UDP port, and then you always use them conceptually. And then the second one about like battery powered devices aren't just a light switch. Like my phone's a battery powered device, my watch is a battery powered device. They're all performance sensitive. If we can really improve the throughput on this and the battery life, I think that's really important for users. So that I think there is a viable use case for this.
All right, so we will take that to the list. Anyway, I think I need to get more reviews on this document before we actually start adopting as a working group document. And how many actually have read this document? Oh, quite a lot of people, but no reviews, no comments. Everybody so clearly understand what it is and didn't see any reason to comment. Okay, send those comments also to the list. All right, the next presentation is.
So, so I'm presenting on behalf of Mohammed. So that's the IPv6, IPv4 coexistence. I got the switch. So, so the idea is to provide an indication of whether you can configure your interface with an IPv4 or an IPv6 or both, or only one, but you have to choose, etc. So the address family failure reasons could be that an initiator asked for one IPv6, which is not supported, in which case the message should be unsupported address family. You have a case of an initiator that requests both IPs, but only one is supported. So you specify that IPv4 only is supported or IPv6 only is supported. And you have the case where an IPv4 and an IPv6 is supported, but so either one can be provided, but you have to choose one. I think the use case is really 3GPP. So that's my understanding is that it is how it is negotiated with the radio access network, and so they want to bring that to wireless.
So Valery Smyslov, and is the first notification really needed? I think the second and third covers the first case as well. So if initiator asks for IPv4, but not IPv6, you return IPv6 only supported. And if it asks for IPv6, not for IPv4, you return IPv4 only supported. That's the first notification seems to be unnecessary.
So what you're saying is that if the initiator asks for both,
For both, you've already covered.
yeah, that's right.
I mean the first case. If it asks for one, but the wrong one, why don't you reply with the second or third notification and they cover all the cases, I think.
Maybe
there
support
are
none. Maybe it's not supporting any of those.
So, Tarokivian, I think actually, yes, there is too many notifications here. I think we can actually, I think we already have the unsupported address families, or I think we had that in currently already there, which means that if it can't give you anything, you should fail. Okay, now the question is, if it supports both, if it sends both, why don't you just return one? Return configured parameters for, if you ask for IPv4 and IPv6 and only returned IPv4 addresses, you know that it doesn't support IPv6 because it didn't give you anything.
Yeah.
And the same thing with the next one. The last one is the different one because there we you asked both IPv4 and IPv6, and you could get either one of them, but not in the same essay, or not in this, at the same time. So the single AF supported is or required is actually. We had the same thing with the traffic selectors. We have a single address required or something like that. So I think that's actually so we could probably remove it to 2 or something like that. But actually we're all right. That's
Ranzicality, aren't these essentially 3GPP error codes?
yes.
Yeah.
So that they like their error codes is like. I mean, there's all these elaborate requirements around them, so it's like, well, if you do this, but then you do that, and then this other flag is set, and the bits 3 to 7 or 1, then you need to return this error. So is there a reason, other than this doesn't make a lot of sense at all? Is it actually harmful to do this? Because a lot of that stuff doesn't make sense, right?
Because I think this is actually the processing rules for them.
I mean, I see. And do these processing rules actually match what the 3GPP specs say?
I think so.
Maybe.
I mean, all the comments are for Med. I mean, I'm just presenting, so.
Okay.
Do we have still one more slide, I think?
Yeah. So that's, he wants to update the IP to RFC. And whether we choose error or status type, I think the choice is to go to the status type. So that's what do we somehow, well, the idea is he has 2 options. So either he has what the code is defined by one options, or it has a different option per notify payload. I think he's looking for assignment of for new status type. So I think there are some objections. That's my understanding. And I think there are also some I also think the message is that we should reduce the number of status type. So that's the 2. And well, one question I had is, should we go to status type, or I say we, but the question I had is, shouldn't we decide an extension and negotiate this extension, the support of that extension?
No, I don't think so. But anyway, so we are running out of time now, and I think I would actually like we already adopted this draft as a working group document. There was already comments on that saying that okay, this could be simplified, and now I actually want people to go and read it again and send the proposal to the mailing list, and so we gotta get this working. They wanted to get it out soon. Because I mean, one of the problem is that okay, they are going to be shipping stuff anyway, and they're actually copying our stuff in their standards anyway. So if we are not ready they will put some numbers there anyway. So that's why I would rather them to put our numbers and our meaning of them than to invent their own. One more comment on them. All right. Okay, so anything else? That's for that. I think we are going to be getting one comment on something else, and then we are going to be finishing.
Okay, you have Mayor and also Chair of I2NSF. The next meeting in this room is going to be I2NSF, and the first thing we're going to, well, after the hackathon report, is about the configuring IPsec gateways with SDN controllers. And if anybody has been to an I2NSF meeting, you probably remember case 2 that was controversial, and we're going to try to discuss this out of existence, discuss the problem out of existence at the start of I2NSF. So I encourage everybody to come in. To whet your appetite, we're going to use the terms FIPS and cryptographic boundary in the discussion.
All right, we are done. If you haven't signed the blue sheets, they're still here.
So do you think when do you think we